Alright guys, today we'll be looking at how to graph parent functions and their translations. This is in Unit 6, Section 5. Our objective, the student will be able to graph parent functions and their translations. First off, parent functions. Parent functions are the most basic version of a function. So the parent functions that we're going to be looking at are f of x equals x, f of x equals x squared, f of x equals x cubed, f of x equals the square root of x, and f of x equals the absolute value of x. Okay, so these basic functions are called parent functions, and every graph that you create is based off of them. So f of x equals x, first off, this is a linear function. Meaning it will give you the graph of a straight line. Okay, f of x equals x will always give you the line that cuts diagonally through the coordinate plane. And we always want to label our graph, so f of x equals x. F of x equals x squared. If you don't remember what this is called, it's called a quadratic. And its graph will always give you a parabola, which, if you don't remember, it's a U-shape function. So let's go ahead and graph that. F of x equals x squared will always have its vertex at the origin, and since it's positive, it will always be facing up. Okay, so this will always be the graph of f of x equals x squared. The third function is f of x equals x cubed. This is a cubic function. Cubic functions kind of look like sideways z's. They give you a little zigzag pattern. Okay, f of x equals x cubed will always cross the origin. Okay, there's a theme here. Parent functions always cross the origin. But anyway, f of x equals x cubed, it crosses the origin, and its graph, like I said, looks like a little zigzag. I didn't really hit the middle, but you get the idea. This is f of x equals x cubed. This parent function and any function that has a cube or a exponent of 3 will always look like this. Okay. Next we have f of x equals the square root of x. This is called a radical function because we have that square root symbol. Square root symbols are called radicals. So this gets us a radical function. It's going to start at the origin, and it's kind of like a parabola, except it's sideways, and there's only the top side to it. We don't have anything down here. So this would be the graph of the parent function for a radical function. The last one we're going to talk about is the absolute value function. Absolute value just means whatever you plug in, it will kick out only the positive value. So if I plugged in -2, it would spit out +2. So everything is going to be positive, meaning everything is going to be above this x-axis. It crosses the origin, and it is a V-shape. So every time you see a function that has the absolute value symbols, know your graph is going to look like a V. If it has a square or a 2 exponent, it's going to look like a U. If there's no exponent, it's going to be a straight line. If there's a square root symbol, it's going to be half of a sideways parabola. And if there's an exponent of 3, or it's a cubic function, it's going to give you a kind of sideways Z zigzag pattern. So the things we're going to be talking about is taking these parent functions and shifting them up and down based on vertical translations, which is what you see here. Vertical translations move or shift the graph of the parent function up or down. For example, if our parent function was f of x equals x, then to shift it up, we would see f of x equals x plus some number, in this case k. To shift down, it would be f of x equals x minus some number, again in this case k. K is just an example. There will be a number there in place of k. So we're going to go ahead and get started. Okay. This example says graph f of x equals x squared, f of x equals x squared plus 3, and f of x equals x squared minus 1 on the same coordinate plane. So we're going to start with the parent function, which is f of x equals x squared. Remember, it's the parent function, so literally all we have to do is look up here. That's our parent function. This is what the graph has to look like. So that's what we're going to graph. Okay. A dot at the origin and a U going in the positive direction. And we're going to label. We always want to make sure we label. So this graph is f of x equals x squared. Next, we're going to shift up, and that would be f of x equals x squared plus 3. So I'm going to take the dot from my parent function and I'm going to move it up 3 spaces. So 1, 2, 3. This is where my dot is now going to be, and then all I have to do is draw a U that's going up, and this is going to be my new function. I'm going to label it right here. F of x equals x squared plus 3. Then we're going to shift down. And that function is f of x equals x squared minus 1. So again, I'm starting at the origin. You always start from the parent function. Don't worry about the blue function. It's drawn. We labeled it. We're done. Okay, forget about the blue function. Go back to the black. Now I need to shift it down. It says -1. So I have to go from the black dot down 1 space. That's where my dot is now. And I'm going to draw a U going in the positive direction. And then I'm going to label f of x equals x squared minus 1. All right, so this is vertical shifts of the parent function f of x equals x squared. We're going to look at 2 more examples. In this example, it says graph f of x equals x, f of x equals x minus 4, f of x equals x plus 5. Okay, so first off, f of x equals x is the parent function. I'm just going to use a ruler to help me out here real quick. And I'm going to label my graph f of x equals x. Then we're going to shift up. Okay, the function for shifting up is f of x equals x plus 5. So to shift up, since our black graph f of x equals x, since it crosses the origin, I can just put a little dot here. Shifting up, it says plus 5, so I'm going to go up 5 from that dot. 1, 2, 3, 4, 5. Then I'm going to take out my ruler again, make sure I have the same slope as my black graph, and I'm just going to move it up to where it crosses that 5. Then I'm going to draw my line for my new graph. And this is f of x equals x plus 5. You always want to label your graphs, just so there's no confusion. Then we're going to shift down, and we're going to graph f of x equals x minus 4. So again, forget about the blue graph. It doesn't mean anything now. We're done with it. We're going back to the black graph, and we're starting at that dot. It says f of x equals x minus 4, so I'm going to go down 4 spaces. 1, 2, 3, 4. Then I'm going to take my ruler. Since it's a straight line, make sure I have the same slope as the other 2, and just put it on the 4th tick mark. Then I'm going to draw my line. And I'm going to put my little arrows and label f of x equals x minus 4. Okay, great. So that's that graph. Our last example is f of x equals the square root of x, f of x equals the square root of x plus 3, f of x equals the square root of x minus 2. And just like always, we're going to start with our parent function, which is f of x equals the square root of x. Remember, this graph also starts at the origin, so we put a dot there. Then it's just like half of a u, except it's flipped on its side. And there we have it, f of x equals the square root of x. Now we're going to shift up f of x equals the square root of x plus 3. So from the black dot, we're going to go up 3 spaces, 1, 2, 3. We're going to draw a new dot, and we're going to draw our graph. And we're going to label. Then we're going to shift down. So we're going to forget about the blue. We're going back to the black dot. So from the black dot, we're going to go down 2 spaces, draw our new dot, and our little curve. And label. And there we have it. All right, that is vertical translations of graphs of parent functions.